Hey guys, welcome to my channel. In this video, I'm going to go through this LeetCode number 5, longest palindrome substring. This question was asked by this many companies in past 6 months. It's a very popular question, obviously. So first of all, what is even a palindrome? So a palindrome is a word, number of phrase, or other sequence of characters which read the same backward as forward, such as this word, right? If you go back forward and the backward it reads exactly the same. Also, the word race car, right? If you go from the front to the back, it's race car. From the back to the front, it's still race car. So this is the examples of a palindrome. Let's come back to LeetCode. So the problem that we are given is to look at to find the longest palindrome substring. Some example: BA, BAD. So one substring that is a palindrome is a BAB, which is exactly that over here, and also ABA could also be a answer. Second example, CBBD. So BB is a another case for a palindrome, which is a repeated. You have two repeated characters. A by itself, one character is also a palindrome. AC, only one character, right? Which is the longest palindrome. And you can choose A or you can choose C, whichever you like. And also there's some constraint in here. We are going to solve this problem using dynamic programming. But before going there, let's go through the brute force approach, right? To find all the substring, where in the brute force approach, it will cost us big of n square, because basically we have a double for loop. We have the first pointer, and then go to find the first character, and the next one. And for example, find all the substring started from if a letter B will be BA, BAB, and BABA, BABAD. So as you can see, and then we go through each one of the starting characters, right? So that will be n squared, and then we fill all the substrings. To validate that substring is a palindrome, that takes n as another n. So if we use a brute force approach, we will take big O of n cube. So that will be very slow, and we will optimize that to reduce it to a big O of n squared. Let's look at the dynamic programming approach. So let me zoom in a little bit. As you can see, we can have a DP, which stands for dynamic programming, n by n grid. And on the left, on the row, we have the starting position, and on the column, we have the end position. So this example, BABAD, this exactly this first example, right? BABAD. And for example, if that's a palindrome, and in this dynamic programming grid, you just put in a number for that length. So for example, the easiest one is the one in the main diagonal, and this is only on the upper half of the, because the down below is just, for example, it started from A and cannot end with B, right? Because the B comes before the A. That's why it doesn't make sense to fill out the lower half of the triangle. So it's only upper half. And for the first diagonal, the main diagonal over here, we started with the B letter, ended with the same letter, right? So all of them are palindrome by itself, right? A and A, B and B, and A and A, and D, right? All of them, they're just a single character palindrome. So pretty understandable. For the second diagonal over here, 0, 0, 0, 0, and they start with B and ended with the start with one character and ended with the next character. So for example, started with A, ended with I started with B, ended with A, and this one started with A, ended with B. So this substring, this is for this part, right? Because it's not a palindrome, that's why we put a 0 in there. The length of that palindrome. which is not a palindrome, is 0. And the B and A, right, again, and so this substring is not a palindrome, so it's 0. And the last one, and the A and D is not, again, it's not a palindrome, that's why I put a 0 in there. And the rest of the upper part of the triangle, we have the rule to fill them all out, is that, for example, if we have a string of BAB, right, so for example, it's BAB, this is that string. So if the middle one, so anything in the middle, it is a palindrome, plus the first character is the same as the last character. That means we have found a new palindrome, right? This is where this dynamic programming, the DP grid is useful. That can save us a lot of work that we have done before, right? We don't repeat our work. So an example, right? This I talk about. So for example, BAB, right? And then we look at, so for example, the starting position is B and ending position is B again. So, and then we have a starting index and end index if they are the same character. Look at the orange string. Also, everything in the between, it is not 0. That means it's everything in between, it is also a palindrome. And then we look at the length of the palindrome in between, plus 2. 2 being the first character and the last character, right? And then we can use this formula to fill out the upper part of the triangle. So the way to fill out the triangle is layer by layer, right? We've already finished the first two layers, first two diagonals, and then we can go to the third diagonal, fourth diagonal, and the fifth diagonal. So how to find these diagonals? As you can see, use this formula. The column index minus the row index equal to some constant for all the numbers in the diagonal. For example, for the main diagonal over here, the column index is the same as the row index. That's why the column index minus the row index equal to 0 for all the number along this diagonal. For the second diagonal, the column index minus the row index equal to 1. And that's all. So all the number on the second diagonal follow that rule. The third diagonal, where the column index minus the row index, in this case, column index equal to 3, row index equal to 0. Take the difference, all of them equals to 3, etc. So I think we got all the ingredient to make this work. And feel free to pause the video at this point and code it up yourself. And now I'm going to go through my solution with you. So first, we need to create that n by n grid. I call it DP, which stands for dynamic programming. And I initialize them, all of them as none. So none times n and append it to the DP empty list. And then I have a max length, which keep track of the length of the longest palindrome. Also, I have the start and end position for the longest palindrome that we keep track of. So this is some initialization. And then I have the first for loop, and this one just to fill out the main diagonal. So basically this one filled out this main diagonal, right? 1, 1, 1, 1, 1. And then I have a for loop in here. So basically this chunk of code, what it does is to fill out the second diagonal. So if the I plus 1 is less than or equal to n minus 1, basically is if n is I plus 1 is within the boundary, okay, and we check if that is, whether that is a palindrome or not, right? If the ith position of the S string is exactly equal to the next character, that means we found a new palindrome. And so the length of the palindrome is equal to 2 because we have 2 characters for that palindrome substring. And at the same time, we update our max length where we initialize as 1. Now we have a max length of 2. At the same time, we update the palindrome position, start and end position. And else means that it is not a palindrome. That means it's the length of the palindrome is 0. Just put in a 0 in there. Okay, so now this block of code allow us to fill out the first diagonal and also the second diagonal. Now we're gonna fill out the rest of the upper part of the triangle. I remember we have to solve this formula, right? To find the, I call it this diagonal is equal to the column number minus the row number, which is equal to some constant. And we finished the zeros diagonal, the first diagonal. Now we're gonna do the second diagonal onward, right? So for D in the range of 0 to the range of from 2 all the way to n minus 1, and for the row also it is a started index. Basically we scan through the row. I call it R star. Basically it's a row index. Also is row index of the DP matrix, and also the starting point of the substring. That's why I call it R start. Just make it easier to understand. In the range between 0 and n minus 1, right? Because basically we scan through each of the rows for a particular diagonal. Again, we loop through all the diagonal in the first in outer for loop. And now after we have the D, after we have the R, and then we can apply this formula. We just rearrange the term, and then we find that the column index equal to the row index plus D, right? And this is exactly that. Column and again, N means the ending index of the substring, and C means the column index. I combine the two of them. That's why I call it Cn equal to D minus R start. If Cn is greater than n minus 1, that means we fall out from the boundary. So we don't have to do no more for the R start, right? And then we just break this for loop. Otherwise, and now we can apply this formula, right? This formula. So if the index that character is equal to the start index of that character of the substring is equal to the n index of the n character of the substring, and also the content in between these two indexes, they are also a palindrome. That means we have found a new palindrome which is longer than what is inside, and we just add 2 to what is inside, the length of what is inside, right? And why is 2? Because we found the 2 additional characters, which is one is this character, another one is this character. And at the same time, after we find the new palindrome, we update the max length, right? And now here we checking the length. Is that greater than the max length? If it is, we update it to the current length as the max length. Also, we updating the starting and index of the longest palindrome starting point and end point. And also we have the else statement, where if one of these two conditions is not met, means that the first character is not the same as the ending character, or anything between the two is not a palindrome. That means if one of these conditions is not met by itself, it is not a palindrome. That's why I just assign a 0, meaning that the length of that palindrome is 0. It simply is not a palindrome. So yeah, so this is the end of this for loop. This takes a big of n square. And same for space complexity. This entirely comes from the DP array. And after that, we just simply return the longest palindrome that we've been keeping track of. Again, the start index, so the end index within this array, within the given string. Let's run that. And it works. Even though it's not very efficient, but my code is pretty clean and understandable. I hope this is helpful. If it is, please like and subscribe, and I will see you in the next video. Thanks for watching. Bye-bye.